called BKwai. And as a little bit of background, I actually grew up in Sheffield, despite what the accent might suggest. And I went to school there, and towards the end of my school career, I was in the position that every young person is, trying to decide what to do with my life. And I was looking around and trying to work that out, and trying to figure out, well, what can I do that would make an impact? Now, I grew up with a family that actually comes from Sri Lanka. My parents left Sri Lanka during the time of the Civil War. And so I learned very quickly what it means not to have basic infrastructure in our built environments. So things like power, things like road networks, things like good water supply, and all of these kinds of things. And I realized very quickly that the built environment, the buildings we live in, the roads we travel on, the trains we take, the water that is supplied to our taps, are critical for people, and it makes a really big impact on people's lives. And then coming back to growing up in Sheffield, you know, we get to take it for granted that when we turn our lights on, the lights will switch on, we have energy. When we turn on our taps to brush our teeth, the water will be there. When we want to get from Sheffield down to another city, we can take the road, the train, or whatever bus, whatever we want to do. And so I was fascinated by this idea of going into a career in the built environment and solving some of those big challenges. And so I worked as a civil engineer, designing things, getting them built, looking after how they're maintained over time. And as I went down this journey, I noticed that actually we still have a really large set of global challenges left to address. So within our sector, we have a number of problems, starting with poor productivity and profitability. And so this is the idea that actually in the construction sector, our bottom line, our typical margins for a construction company is something like 2 to 8%. And that causes a lot of problems in that it traps construction companies into stagnant productivity and trying to squeeze out every little penny. We're not that good at dealing with that issue, and it only takes relatively large recent projects to show us how bad we are at that. So if you know about the Crossrail project in London, this is a new underground train line going across east and west of London. But the thing about this project is that it is several hundred million over budget, and it is several years late. And so we're having issues in trying to deal with profits, deal with productivity, and deliver like high quality projects on time and to budget. Added to that, well, actually one of the biggest sources of waste in this country is the construction sector. Through the waste products that we have from constructing things, due to demolishing buildings, all of this kind of stuff ends up in landfill. And we're trying to get better at reusing buildings, retrofitting buildings, reusing materials as much as we can, but still quite a lot of it goes to large landfill. Then, of course, there is the climate crisis. This is a threat where we must take action now to avoid catastrophic impacts, and we all know that. Infrastructure, I read, was actually accountable for about 70% of the world's CO2. So that's not just constructing things and putting lots of iron and cement and steel into our buildings, our roads, our bridges, etc., etc. It's also incorporated in how we use things. So as we use buildings, as we generate energy, as we use our public transport systems, as we use our digital systems, our water systems, these all have some element of carbon to them. And understanding the whole life cycle of our carbon input in our infrastructure, in our buildings, in our roads, in our energy as a whole system is something we really need to do in order to address some of our climate crisis challenges. Then, of course, there's climate crisis as it impacts our infrastructure. So I don't know if you recognize this bridge. This is a bridge that collapsed in Ireland in about 2009. And the scary thing about this bridge is that there was a train that drove over it, and the train driver on one busy Friday evening after work noticed the bridge crumbling beneath him, which is absolutely terrifying. And thank goodness they managed to coast the train clear of the collapse. But this bridge actually collapsed because of something called scour. And scour is where the water pattern changes slightly, and then the foundations on which the bridge sit on are worn away, creating a hole under the bridge, and the bridge suddenly collapses. And so if you think, wow, that's a little bit scary, what's even scarier is that happens a lot all over the UK over the last few years. And these sorts of problems only get worse and worse with climate change, causing flooding, causing a change in river flows and all these kinds of things. And so increasingly, it's not just building structures we need to worry about, but actually keeping them healthy and safe over the long-term period. And so I went into this career aiming to work on big challenges. And at the start of this, I might have mentioned, I decided I would do an engineering degree. Engineers have the great opportunity where we get to work on lots of problems, learn about science, but then also learn about how to put that into practical solutions. And so as I went down this journey, I tried to learn a little bit more about, well, how do we make change? How do we solve some of these global problems? And what do we do to be more innovative as an industry? How can we tackle some of these really big problems? And so I'm going to tell you a series of stories from different companies and different experiences on what I learned along that journey. So innovation can come in many different forms. This is an example from a company called Lang O'Rourke, who have a factory actually just down the road from Sheffield in a place called Worksop, where my family are currently based. And Lang O'Rourke decided that, hey, you know what, the way we build our structures, the way we build our buildings, the way we build all this stuff is the same way we've always been doing it. What if we made this factory and instead of just building things on site, we created something that resembles something akin to a car manufacturing plant. So you have these systems where you can build parts of buildings, so parts of walls, parts of columns, parts of bridges, in a high quality, much safer environment, built to very high quality design specs, and deliver things in a different way. So rather than turning up on site, mixing our concrete, batching everything together, and doing everything in quite dangerous conditions, they've decided to flip the entire script and build something by designing it to be manufactured in a safe, high quality condition and assembled on site. A little bit like you would with Lego. You just bring it to site and put it together. Not that simple, but that kind of analogy. And so this is one company who decided, okay, we're going to do things differently. And they made quite a significant investment on their part to say, hey, we want to do things differently. Let's put our money where our mouth is and let's try to do something different. And so that's one end of the innovation scale where you take the step forward and you make a big leap of faith and try and shift the rest of the industry with you. I next want to talk about a very different end of this scale. Another part of my career took me to Peru, where I was working in an area that was affected by an earthquake. And even 2 years after the earthquake, a lot of the structures still hadn't been built and we were still working on reconstruction programs. So people are obviously desperate to get back to their homes and rebuild. And the temptation is to rebuild something similar to what was built there before. So you can see in this photo, lots of buildings made out of bricks and unreinforced masonry and things like that. The problem with this is that after an earthquake, this happens. And so I was working with an organization called Predes, who are based of a mixture of different people who have lots of different perspectives. So we had engineers, we had architects, but we also had planners, we had local community workers, we had anthropologists, we had government interaction community workers, and all sorts of different people to gather different perspectives. And the interesting thing, what Predes did was not just build something to replace what was there, and it wasn't just build something as you would see anywhere else, but it was to look at what was appropriate for that surrounding. And so this is an example of a building that's in central Lima, and it has been built several hundred years ago, several stories high, and withstood that same earthquake. Now, what's interesting about this building is it's not made out of masonry or concrete or any of the quote unquote modern construction techniques that we're used to seeing. This is built out of something called quincha. Quincha is a building method that existed in Peru for several hundred years. And effectively what they're doing is building something wooden that has a little bit of flexibility to it and then putting a covering on it. So this is an example of an old building which you can see the wood through it, which I use as an example. There's other buildings where the covering is a bit cleaner, but it doesn't illustrate the points as well. And so what Predes did was look backwards to history and bring that forward with a kind of modern update. So they built something what they call quincha mejorada, or improved quincha method. And essentially what they did for each community, each household, was dig the foundations, put in wooden posts, and build the frame of a structure. between the wooden posts, they would put what you see here, this interwoven cane, which is called quincha. And quincha is a little bit something like bamboo, if you can imagine it, quite flexible. And then on top of that, they put a kind of earth cement render to smooth the walls, tie it all together, and then paint it up. So that when the next earthquake comes along, these structures are able to withstand the earthquake, maybe with a few cosmetic changes needed, but without that kind of big pile of rocks. And so the community were quite unsure about how to take this, and as they were kind of interested in building back with brick and building back with concrete, because, you know, in wealthier parts of the city, that's what they would use, or in the Americas, that's what they would use. And so why shouldn't I have a brick home? Why am I building mine out of wood and render? And so actually what some of the communities did, and you can see it in the picture on the bottom left, is people liked the idea of brick because it was the aesthetic they wanted for their home. And so what people ended up doing here, what Preda suggested, was that they actually score the lines and they actually painted the brick. So it looks like a brick finish in the end, but it's actually much more suitable to that condition. And so this was a case of a kind of innovation that came from looking at what was there and bringing something back from the past, but in a way that also worked with understanding what people needed and what was relevant for the current situation. And I really like that kind of example. So back to the UK, we also have a large number of global challenges that we have to face. One of the big problems for us, especially in the Sheffield area, is things like flooding and the impact of flooding. And so when I was younger, I remember actually going to school and several of my school friends having to be evacuated in the middle of the night from their homes because they lived, I think it was somewhere near Rotherham, and the banks of the dam were ready to burst. And that's a terrifying position to be in, to have your homes and your livelihoods under threat. And so still for us, there's a lot of opportunity to really impact the built environment and stop these kinds of problems, or at least impacting the people. And for me, one of the big solutions is this digital sector, the sector that we're all in now. This idea that we could learn quite a lot from building things and modeling things and understand things in the digital sphere, and then connecting that to the built environment in the real world. And so what I ended up working on was basically putting together technologies and understanding what other people were doing in other sectors, and trying to figure out, well, okay, here's what I can learn from these other sectors and how can that impact us in the built environment. One of the pieces of the digital puzzle I started looking at was satellites. Now, I don't know how much you know about satellites, but they come in all shapes and all kinds of sizes. This particular one is a satellite called SAR, or synthetic aperture radar. So it flies around the world and it takes something like a picture, but instead of like an optical picture, it emits radar. The radar hits the ground and it comes back to the satellite and it images this radar. And what you can do with this radar is understand how things are moving on the ground. So if you can imagine a radar wave being shot from the satellite, hitting something on the ground and coming back, the next time the satellite comes around, it then sends out another radar wave, hits the ground and comes back. And between those two radar waves, you can measure a shift in the wave. So if you think about something like your police radar, so if you're driving in a car and the police is pointing their radar gun at you, that can measure the speed of your car. Similarly, as objects move slowly on the ground, we can use radars from space, about a few thousand kilometers up in space, and measure the movement of the ground. So what you can see here in this picture are various different points that are giving us reflections over the city of London. And what I've circled in red is a patch that, if you look at the scale, is sinking over time. Everything else looks relatively stable, but that patch is sinking. And then you look into the story and you find out that actually that is a new tunnel that they're building in London. And when you build a new tunnel, the buildings onto the surface of the tunnel, just above the crown of the tunnel, they tend to settle a little bit. And so what we can do is use satellites to monitor the built environment and see how things on the ground are moving. So in this case, we can see the buildings on top of a tunnel settling. Back to the example I was talking about related to flooding, one of the projects I started looking at was, well, okay, if we can see things moving, and we have this problem where bridges are collapsing due to flooding and scour related problems, can we use this type of satellite radar to measure points on the bridge and spot how they're moving over time? So for this particular bridge, I processed the satellite radar data over this bridge, concentrating specifically on that point in red. So if you look at the image on the left, these are all the points I collected from an area over Tadcaster in North Yorkshire. In the dark line, you can see the river. This is a road on the right, and the points in the blown up screen, that is the bridge. And so what we're interested in is the movement of these 1, 2, 3, 4, 5, 6, 7, 8 points on the bridge over time. We're especially interested in that red point in the middle, because that's the point where it actually collapsed in real life. And so every time the satellite passes around, it collects an image, and so we can have a measurement point. And so if you look at these measurement points over time, you can see that in 2014, they move around a little, but they're generally fairly stable. In 2015, again, generally pretty stable until we get towards the end of 2015. What happened at this point? Well, there was a big flooding event. And what's really interesting is that whilst generally the bridge stays fairly stable, that point, that red point in the middle, you'll notice it moving further and further away from the other points, quite significantly. And actually on the 29th of December was where the collapse had happened itself. So I was really interested in whether we can start incorporating these types of satellite techniques that we're learning from the space sector into monitoring our own assets and our own bridges and our own communities to help make smarter maintenance and asset decisions. And actually, in terms of satellite data, there are a huge wealth of opportunities. You can measure digital elevation models, you can measure the effects of forest fires in forest areas, you can measure air quality, and you can measure all kinds of different parameters that tell us about how our built environment is behaving. And if you put that together with various digital technologies, you have a really powerful tool in helping us monitor in real time what's happening on the Earth and help us make decisions now that could impact these types of assets in the future. So one of the other things that satellite data can do is tell you a little bit about how areas are changing over time. And we can do that using visual data. You know, anyone can go on to like Google Earth or Google Maps and see that physical change. So here you can see quite quickly that actually this area has changed over time. But combining this with other different types of data can give you even more information. So we can then process something that tells us a bit about height. So each of these blocks are a different height. And so we can see not just what has changed, but how it has changed and how the whole demographic of our area has changed over time. And the other interesting thing about satellites is that their resolution is getting better and better. The spatial resolution is getting finer and finer, and we're getting more frequent data over time. And so the opportunities for what we can use this for is really starting to open up. And what we really need to do to bring forth this innovation is to get one community, say the built environment, to talk to other communities, say the space sector, to really understand how the two can work hand in hand and drive that innovation going forward. And actually now we're in a position for the built environment where we're actually getting pretty good at collecting data. We collect data, as we've mentioned, from satellites. We collect data from social media, from Twitter posts, from Facebook posts. We collect it from attaching embedded sensors. So by sticking sensors in the ground that can measure tilt, that can measure temperature, that can measure displacement and all these kinds of things. We get it from material flows. We are inundated with data. But there's still one problem. It's not just enough to have data. You have to be able to use that data. And so the challenge that I faced at the time we were starting this company was, yay, we have all this data, and that provides some really exciting opportunities for the construction and infrastructure sector. But if you can't access the insights from that data, if you have a huge mass of data and don't know what's important and what's not, and where there's a warning sign and what are the important bits, then you can't really get any value out of that data. And so for us, we ended up building a product that tried to address some of these problems. The construction sector in particular, we're pretty old school in the general sense. We're moving towards the digital sector, but we really love things like spreadsheets. Now, spreadsheets are great if you have 1 or 2 points to measure or a bit of manual data. But imagine having tens of thousands of sensors, collecting data every 20 seconds, every 2 hours, or what may be. You end up with a huge data problem, and Excel just isn't going to cut it. And so we worked around bringing together people from the built environment, people with data science methods, university collaborations with the University of Cambridge, and building together a software platform that could really understand what was happening. So that rather than spending time plotting lots and lots of graphs with lots and lots of spreadsheets, we can get people to make intelligent decisions and provide people with insights to make smarter, faster, safer decisions on sites. Thinking about our asset management, so our bridges that are at risk, the way we monitor those now is to periodically visual inspect them. And that means that, say, for example, every 6 years, you're looking at a bridge, or every 2 years, or whatever frequency the asset owner decides. If you're only looking at a bridge every 6 years in detail, that means that something could happen in between. And as we've said, the climate crisis means that our environmental conditions are changing. Summers are getting hotter, winters are getting colder. We're throwing more ice on the road that accelerates corrosion in our steelwork. We've got these flood effects that we've already spoken about. And so if these things are changing, what we could do is actually collect data from lots of different sources, combine them together, combine them with a bit of human knowledge, and support preventative maintenance, trying to prevent these things from failing rather than dealing with the collapses afterwards. And so for us, our company is all about accessing these insights by putting together data from sensors, data from satellites, data from environmental sources, data from the weather, to try and forecast forward and then kind of give ourselves a little bit of a crystal ball on how the built environment is behaving. And the exciting thing about putting all these different data sources together in a digital environment is that they each tell you something different. So I don't know if you've seen this image before, but it's one I really like. It's based on a kind of old tale, I think it's from the Indian subcontinent, but effectively it's this idea that it's a story about lots of people, I think it's like a story about 7 blind men or something like this. But if you imagine all these blindfolded people and they all are touching one part of an elephant. Now, each of these people feels something completely different. One person thinks it's a fan, the other one strokes the tusk and thinks it's a spear, the other one's touching the side and it's a wall. And they're all getting a very, very different perspective on what is the same object. So for us, the digital opportunity for me in this sector was actually putting all of these sources together and saying, okay, each of these sensors, it tells us a tiny little bit about the structure itself, but the real value comes from putting that all together and giving people the tools that they need to make these better informed decisions and access these insights on how your bridge or your tunnel or your building or your water system or your dam is behaving over time. And one of the biggest lessons I've learned in that journey and where we were building this new piece of software is that actually the best ideas come not just from the digital sector, but from the people working in the digital sector. And going from the built environment to building software, we really learned about the value of having a diverse team to understand, for example, user experiences. Different people will access the platform in different ways, and it's not just enough to say, here's some really nice tech that we've developed in the university, and now it's suddenly useful for everyone. No, there is plenty of university technology that is not in the real world. And what you really need to do is have people who can not just do tech, but do design, do user experience, do engineering, do all of these very different careers from very different perspectives to build something that's usable for all kinds of people. In the similar way that we need to build cities for a diverse range of people, we also need to deploy digital solutions that reflect that diverse sense of people as well. The team also brings a diverse range of ideas. For example, I come from the built environment, so to some extent, I'm a little bit skewed by the system. Whereas other people that work in my team, they come from really, really different environments, people from other sectors, other technology stacks, other types of experience, and a whole range of ages and backgrounds, which means that actually our solution benefits from having a wide range of ideas. And so it becomes not just a tech or a digital story, but the story of how people can work together to develop these new innovations and develop solutions that are really not just technically interesting, but relevant for people, society, and the built environment around us. And so back to my journey towards innovation, I started it with engineering, and all along the way, from these different examples, from these different stories, from building the company, I've learned that actually innovation doesn't come from one big leap forward in making innovation. It comes from learning about people. It comes from learning about design process, about responsibility and improvement and communication. And the key to innovation, or at least radical innovation, isn't just coming up with the bright idea. It's the journey along the way towards that final solution. So I want to say thanks very much for listening to that, and yeah, happy to answer any questions.